Good morning. Good morning. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India. On this day, July 25th, 2021, Sunday, sleeping day, rest day for everybody. But I am still continuing with my talk for benefit of everyone. Quality, safety, COVID on top agenda, COVID, safety and quality. Civil, field engineering, quality AnnexSL, COVID-19, HSC or SHC engineer's role, designs, construction, methods, contracts, organizations, communications, coordination, etc., etc., etc. Coordination and communication, which is root of everything, which is root of life. And these certificates, every day I show these certificates which tell and demand something from manufacturers, from industrialists. I say manufacturers and I say industrialists, I do not mean owners. I mean those professionals who work with those we work on in factories and in industries for production. I'm interested in those professionals who are responsible for quantity and quality of production, because those professionals are having certain certifications like this is, and otherwise this is, or this is. These certifications mean what? This means your production is also having same quantum of power as your education is, as your training is. That is my stress on quality and safety. I stress daily, every day, with further increments of emphasis on quality and safety, because I understand that our world lack in quality and safety. Particularly our world, when I say my country world, lacks in safety as well as in quality. That is fact of life. One may accept or one may not accept. Quality has fallen, has dropped from its datum drastically. People shall not accept this statement, or may accept this statement, I cannot answer. But fact remains, quality has not reached to a line where it was expected to reach. A consumer is not interested in system of quality. What your factory, what your industry, or what your organization adopts as quality system. Consumer is interested in quality of product. That is very important point. Quality of product and systems must be related, or else there is no meaning of quality system. When there was no such formal systems, I think quality was better in those days. When there was no ISO 9001, and there was no Sigma, front, I understand, I presume with evidence that quality was much better that time because every technicalities was defined. Now what happened? System has come up very higher level, it has come up to systems and systems and systems. You go to whatever organization, small or big, whatever entity, whatever industry, whatever manufacturer, whatever group of people serving you, I will not find, I did not find, I do not find. I am speaking of all these sentences in all forms of present, past, and future. I am unable to find product quality, and that is in 98% cases. Product quality has gone off front. Product quality versus system quality, I think that can be made a title, that can be made a topic. Product quality versus system quality. We have stressed a lot on systems quality. That is true. I think when we stress a lot, we emphasize a lot on systems. Aim of system, objective of system, which is product, has gone in vain because that product is smaller in scale than system. It has gone astray. When you experience whatever product at national level or at international level, if you experience in 2021, well, I am sure your product you buy will not satisfy you at all. And I am talking this about all products. Maybe I don't know how it happens, what is how this bad stage has reached. I don't have clue for that, but I can understand that first of all there is no unison in manufacturing, there is no quality in manufacturing or production, there are no individuals who can be called serious professionals, and when professionals do not remain serious, certainly that organization cannot be serious, and that impact goes to quality of product. That is what is happening. Means I have seen cases, you buy something today and in 1 week you will find that performance is not available which was expected. And in many cases this also happens. You buy some product through online system and you are delivered product. Till time you are delivered, you remain very happy that so much facility is available that at home you get free delivery, just pay online. Yes, that is facility. That facility of free delivery invites your greed, invites your avarice that okay, why should I go to market to investigate product or search for product when I can buy my specification based product online. But when you receive that product, well, I think you get disappointed, and by time you receive that product you will get maybe 5 to 10 SMSs about information what is the status of your delivery. That is main point. We have to be very concerned. Means I have to consider this is a part of quality system that they send you messages, SMS, that this is a status, this is a status. Till that confinement, till that consideration of status of delivery, it's fine. indeed it is fine. But if you go further, after delivery is made to you, when real test comes, and that is product, quality of product, you shall be very disappointed, very much disappointed. In many cases, I think in general, that I did not expect this product, but quality is that bad. If you compare to your requirement, your expectation, that is not even 10% or 0%. When the product doesn't work, I mean, it is a scrap, you can say, means you paid money for scrap. This is really ridiculous, ridiculous. Consumer has been treated nowhere. System has been treated much above. When system is clear, if it is functional, it is performer, you should get quality product. But that doesn't happen. System has produced only delivery system. Our quality system has resulted in good package, good SMS, and good promise that we shall give you this. And that promise is futile. That promise is futile, and futility means loss of money. Every day I talk about this, and you must be feeling very bored and annoyed. Why I'm wasting your time? It's not wastage of time, it is fact of life. Means if you fight with them that you got a bad product, they will bargain with you online, on mail. Okay, I will give you this, I will give you that. That after fighting. And if you don't fight, they will take you for granted. All these manufacturers, they take you for granted. They think that you seek their help, while they should, question of help doesn't arise when they should work. If I pay for something, I should get that. I'm not interested in free delivery. I can pay for delivery also when I pay for product. What's wrong with that? But you give me product just because to save money of delivery. Should I buy scrap? That's my question. Do I pay money? Whatever money it is, it depends on cost of product. Because free delivery can replace your product, you think so? Free delivery cannot replace product quality. But this is what they think. Just sell it, get money, and let consumer run from pillar to post, which is wrong. System should be that I paid you and you give me good product. That is what is system. But here system has been changed to something else. Means delivery is more important, post is more important, courier is more important, parcel is more important than what is contained in parcel. That is status of quality. I can say this quality system is fake, in fact. Fake. You should mind it or don't mind it, I don't care. Quality system has become burden on consumers if it cannot deliver product. It is clearly stated in system definition that this system does not guarantee quality of product. We know that. Don't tell us that system doesn't guarantee that. We know it very well, it doesn't guarantee. Because system is not manufacturer. System is not a company. System is just a few pieces of paper or a small booklet. It is nothing more than that. Certain ideas have been collected at one place in a few lines, in a few pages. Ideas of those professionals who may be engineers or who may be management graduates, or who are only interested in creating a piece of show. If that is okay, up to that means they are just interested in publicity stunt. Quality control does not exist, I can say. Quality control, which is a technical part of work, which is a technical part of your product, that does not work. Problem is that technical part doesn't work means engineers or technicians who are responsible for specifications, implementation, they are not very serious. They are not very serious, or you can say whatever parts are added into your product, all those people are not very serious. Maybe out of 10 parts, 2 parts are good, but 2 parts cannot help other 8 parts. That's what I say. My explanation is that I have no detailed search or survey. What is reason behind such collapse of system? And this collapse lies everywhere. You buy whatever good, you find that. And maybe you are also habitual of certain bad quality because you may be also somewhere involved with that system which produces no quality. That's the important part. I'm not concerned with, although quality system is very important, it defines a company's working, but what I do with companies working if product is rubbish? Well, I think then there is no need of this system. This is rubbish everywhere. If I cannot get quality, system meaning is nothing. I don't want to know how many controllers are there in this project, how many people are responsible for this system. That is not my priority. My only priority is whatever you have given, it should comply to what you claim. But that is not practically working. So what we say, I shouldn't worry about quality system, and I think ISO, International Standardization Organization, is not looking into that. They also think that their mandate is just to standardize materials and not to worry about product. Well, I think that's not correct. Mandate wise they are right, but even those agents, those authorized companies who go and search and investigate such cases, or you can say third party research, search and investigation audit conducted on such organizations also does not have any meaning, because they don't work thoroughly, they work only at random, and at random it depends upon if something comes out, they just write observation, and this doesn't mean anything. Because I am a civil engineer, I was involved in many such investigations, and I know how they work. Though I am not a person of quality specification, I am not a quality person, but I have experience of working, and that experience means I know what is quality system, what is system quality, what is product, and what is product quality. Well, I think we should emphasize on product quality if we emphasize on systems. And if we don't emphasize on quality controls, which is real quality work, there is no meaning of whatever system we are in. I'm not interested in somebody's organizational structure. I'm not interested what are their job descriptions. Yes, that is an interest in project work, in companies work, in manuals, or in whatever quality system we adopt. That is a mandate, but I'm not directly linked to that mandate because it's company that has to take care. My interest is product. Ultimate interest is product. If that product does not satisfy me, that all quality system for me is redundant, for me has got no meaning. That's very important point that we have to understand. I don't want to repeat same thing every day because it's general. In engineering, what is important, what is engineering actually? To be very frank, what do you mean by engineers? What do you mean by engineering? Engineer is a person who is related to facts and not fictions. That is main definition of engineering. Engineering doesn't mean fiction. Engineering means facts. It may be design engineering, or it may be production engineering, or it may be construction engineering. Facts of life, just like fact of our body, fact of our living. Fact remains that I am a alive person, and also fact remains if somebody is dead. When somebody is dead, when soul has gone out of body, that's a fact that that person is dead, and that person is alive. That is also a fact. Both are facts. In one fact, body is disposed of or cremated or graved. In other fact, body works further and further, and health is important in that case. It's like that. If quality doesn't exist, I can call it dead system. Dead system. No more existing system. And if quality works, quality of product works, I would say that that system is alive, that product is alive. Now, how to achieve that quality is important point. That is very important point, and it can be done only by those people, by those professionals who deal with engineering and production. I cannot accept those people who have no experience in engineering or practical work, and they can be asked for defining or framing some system. That is not right approach. Those may be management graduates or maybe some other graduates. Until you have some experience, trained experience, guided experience, proven experience, you cannot formulate a system. And that system, in my terminology, I name it method statement, or whatever statement describing how this is being done, how this product is being done, how it was contemplated, what percentage of achievement we have converted it to that. Many people would criticize my statement. No issue. Everybody has a right to criticize. But fact also cannot be denied. And fact remains that engineering is a fact. It's not a story. It's not poetry. It's not, drawing only, artistic drawing. It is something which uses all resources to convert those resources, using those resources and using available materials into factual requirements. I cannot produce a structure which is not going to be used or which cannot be used just for elevation purpose. Should I do that? No. Fact remains that when I work on some structures, it remains meaningful only when it has certain purpose. If it has no purpose, there is no meaning of investment, of time, investment of money, investment, involvement, cost, risk, taking all risk. There is no meaning of that. It's like some primary student or student of middle classes, middle school, takes up some piece, drawing sheet, and draws some art on that, some painting on that which can be of no use except that I have done it. It looks very attractive, colorful, and teacher would grant some marks on that. That's purpose of that paint. But here I cannot paint. I have to do clear work. It's important. Painting will not suffice. It's like makeup, If you think you're not very handsome or beautiful, you want to hide your, errors, or you can say awkward faces, and you apply makeup on that. But that makeup is instant only, you spend only a couple of minutes or hours, and after that you wear it out. Real face comes up, and real face comes up with further scratches or further stains on that. That real face is engineering, what you are, how you are. When you construct some structure, you find that it is not very beautiful in looking when you construct it. You will find all area where work is done is not very tidy. It's not, giving you any pleasure until you finish that. Time when you finish that structure with all decorations, all finishes, then you feel pleased, and those who watch or view that, they are pleased. So beautiful structure, beautiful finishes. Either they do not know anything about structure, but they are very beautiful done, very excellently it is done. They appreciate like that, but they don't know facts. If I'm very attractive, I'm very handsome, people say, oh, such a beautiful girl or beautiful boy, handsome boy, who will comment on that? But if I say I am sick, I am depressed, I have this problem, I have that problem, I cannot walk physically, I can't tolerate sun, which means though I look attractive by artificial means, but I don't have stamina to walk, to work, to fight, to struggle. In that case, this is only when my body doesn't work properly, I can say my body doesn't work with sure, it's not efficient. Where is system then? System is already defined. Who defined? God defined, God designed. And still, if it doesn't work, what should I say? Therefore, my dear friends, it's question of reliability in profession. Reliability can be defined in many ways, because reliable means it is useful, we can depend upon this, it's not going to defeat us, we are going to use it. Purpose of reliability is not to defeat consumer but to help consumer. Those products which help me, I certainly appreciate those products because they help me only when they work. This is main point, I would say, is very important from viewpoint of quality, because engineering is vast. Engineering is vast, and it may be whatever branch of engineering, all are vast. We must realize this fact also. I'm not happy that why people are not interested in quality. I have no answer to that. How can you say that people are not interested? Everybody should be and must be interested in quality, but there may be some confinement, some obstruction to what is expected from viewpoint of quality, and those obstructions and those attractions, those problems maybe are out of control of that individual who is just an employee or manager or engineer in certain organization. Could be that that person is unable to help self, or there is some other reason that people do not bother. You do not deliver quality does not mean that you did not spend money on that production, on that product manufacturing. Quality-less product could be, but cost remains same. You are using natural material, you are using some technology, you are going to use human resources, you are going to use material resources, you are going to use machine resources. Nothing is saved, every resource is used. Then to say that it's for profit, well, I don't accept that. Product may be rubbish, but it's expensive. It has spent on it material cost, resources, you can say human resources cost, machine cost, and whatever other costs are involved. It has consumed. Even then, if it's not functional requirement, it's not successful. In that we can say something is wrong somewhere, and that is wrong where there is no seriousness in quality controls. Quality controls, though, which should be more important than quality system control, because if material control or production control is not very functional, we cannot get what we want. Ignorance, or you can say condonation, or you can say no botherance towards quality can lead to that one. There is no necessity to accept everything I say. You have to analyze every case. Analysis is very important in engineering and also in life. In my branch of civil engineering, I think analysis remains on top, without which nothing can move. We start with imagination. It may be design or it may be something else. We start with a point of imagination that we can move like this. We can move like this, we can do like this. And our imagination by an engineer is also not which others imagine. Our imaginations are different. When engineer imagines something, engineer also keeps in mind technology. Engineers also keeps in mind required criteria and logics. It's not simply imagination and writing something or narrating something and telling something about something which has nothing. When engineer thinks, it's different world. Imagination by engineer, doing something by mind by engineer are real words, because engineering is played there. Engineering is worked upon there. That point we have to understand. And that means engineer's work means analysis, engineering work means considering every question, trying to find real answer of that can be applied with. That's beauty of engineering, that if you really are an engineer, you must be with facts of life, with truth of life. Life which is measurable, which is powerful, which can develop, which can do whatever it wants or what the other wants. Life is that. That's why we call life of a product as well. We say shelf life of this product is so many months, working life of this product is so many years. We say that, but we don't justify how it is. You try to see whatever material you want to buy, whatever product you want to buy, they would give you guarantee, they would give you warranty. Warranties are risk covers actually for both. Consumer thinks I am safe for so many years to an extent this material is concerned, and that person who manufactures it, who delivered to you this product, has also certain trust that in 1 year or 2 years this gentleman would not come, because I have made product that in 1 year or 2 years this product shall work perfectly. That is only purpose of when life of some work can be, some product can be 10 years, 5 years. Why should I guarantee for 1 year? That's my question. I should guarantee for the whole life. But this doesn't happen. Because that is business trend. They can't take responsibility forever, and they want to keep that stake on your shoulders. You have to spend money on that, and this is great thinking by them. I still hold that person high, the high heads. That person who, in its beginning, started such thinking that we provide certain limited duration guarantee or warranty, so that we are safe. And of course, they include that expected maintenance cost or repair cost of period within guarantee time, and also after that they charge for repair. So in both considerations, that production manufacturer doesn't lose anything. They gain only when you buy a product. Warranty time is included in cost, and you think it's free of cost. No, it's not free of cost. It costs everyone, and once that warranty is over, also you will find that you have to pay for repairs. So for you, it's a double attack. But for manufacturer, maintenance is a kind of business. After 1 year or after 2 years of purchase, whatever be conditions in your sales contract or sales deed, that is only maintenance development, maintenance progress, maintenance cost earning by that manufacturer. We have to keep this point in mind, because engineers can go into much depth, much deeper than what I'm thinking, and understand. I don't understand reason, whatever reason be there. I don't understand why engineers do not speak, why engineers do not fight with such systems. Rather, they support such systems. That is really unpleasant situation, very much unpleasant for me, that if I support some material without investigation, or I include that material in my specifications of project, then I think I do not do justice to anyone. Engineering, we say, engineering is not ordinary term, as term itself says. Means you are a person who can intelligently think. It's not simply thinking. Intelligently thinking, brilliantly thinking, and thinking beyond limits. Thinking beyond limit is nothing very important. It's a good one. If my limits are that, I have to expand my limits. What's wrong with that? I have to expand my vistas, because for that I don't need my expansion of body, just use of mind. And use of mind is very easy as well as very difficult. It's up to your practice. It's up to your practice. What do you do? Safety, when I say safety and health, along with environment, because safety is directly related to life survival. Life survival, remaining safe, remaining healthy, and to try to live in good environment. That is what life survival says. Otherwise, if I get sick due to my own weakness, due to my own system not following or making a good system, then certainly I will lose something. I lose something because of deteriorating health. That could be one reason. We have to be very smart in such considerations, in some topics, in such concentrations, you can say. Everything is out our hands if we are engineers. Engineers can't say all time, of course, that is a presumption. Engineers can't say, because engineer is well trained, and that training has not come just by honor, but by blessings of God and by hard work. God is very interested in engineers. Do you know that? God is also very interested in doctors, because these two professionals are primary one. If you are a doctor, medical doctor, you are not an ordinary person as far as God is concerned, because you you keep human health or whose health safe, you try to treat sickness, you try to do a lot for public, for everybody, for health of everybody, because health is primary requirement. We call health is wealth. Health is wealth. Wealth is not health. Health is wealth. Where is that health? That health also relates to safety. If you are safe, you are healthy, and you are good person, because you keep yourself safe. In engineering, health of system is very important. When we define system, quality system, we just define certain criteria which we have to comply with, and that criteria is defined by ISO or other one. But is that only system? Is that only definition that we have to follow? Well, I think no. That is a system only that covers definition of that coverage, that small policy guide is only based on experience, and I cannot challenge that, because it's safe, it's nothing wrong. But problem is, based on that principle, what do you extract? What do you apply onto yourself? That is important. If I say in my system, we'll elect or appoint right man for right job, very simple it is, very simple it is. We'll procure right material for meeting requirement. We'll employ professional people or suitable people for our job. It's very easy to write. It's very easy to write. Writing doesn't mean anything. It doesn't cost you anything. You can only write. I can only write. It's like electrical supply, which you do not manufacture, but you can connect and use it. Writing such requirements is not very difficult, but continuity of that requirement application is important. Cost is one part, but even after spending cost, if you don't get your requirement, what is solution to that? And if it's very general, if it's very very common, that maybe in 98% cases you won't feel happy. You won't feel happy. You may be good person, you may be good country, you may be good society, if you get quality done. Quality done only speaking doesn't mean anything, because quality must be seen by use of that product, or seen by experience, or using services, whatever services we need, using that services. When we talk of safety, we talk of a lot. This is temporary electrical supply. I talked a lot about this. I don't know how much we talked in this. We talked something, responsibility and that. So let us say what I talked. This very important point of electrical, because this is temporary electricals, and which is also very very important. And after that we can say I should just be, because yesterday there was problem of electrical supply, and also my system, my internet did not work very well. Let us hope that it works today, and I can't answer at this moment, but let us hope it would work. In this procedures of safety, as I say, electrical supply, also there is electrical supply in welding and cutting. Let us see this also. Welding and cutting is about 7 pages. Let us move on to this. Let's move on to this also and see how it's done. So we'll talk of this first. Talk of this first. Temporary, we have to get for everybody temporary supply on sites or wherever where there is no permanent supply, on projects particularly. Generally all projects in world, very limited they get supply from state or from electrical distribution. If it's available, it's fine. If it's available, you can have it. Otherwise you have to take, even if you take supply from them, that supply shall come to your main board or your transformer or whatever you can call it, your main panel, and after that you are responsible. That main panel may be housed somewhere on a board or a temporary board itself, or maybe on some temporary wall. After that, it's your job to use that electrical energy on your site work. So what should I say? I should say that on construction sites, I'm calling construction sites because in factories lights are not temporary. Same way industries do not require temporary lights because they are established manufacturing units. We can't say that supply depend on is temporary, that's permanent one. Temporary is for temporary work, like construction is a temporary stage. Whole constructions are temporary because projects are temporary until these are converted to operational units. Purpose of this procedure, which I am going to share with you, is to provide controls for use of temporary electrics. Temporary electric is very common on projects, without which project cannot move. It can be provided from main permanent supplies. If available, or also by installing required capacity, fuel operated generators equipped with adequate precautions. On many sites, on major sites, can say many generators may also be required at various locations. On major sites, many generators may also be required at various locations to meet equipment operations and site working demands. Now, you may need generators also. Even if you have supplies, it depends on site working demand and site working location. Sites may be very big, like mega projects, or maybe very small, like one building or two buildings. From such main distribution boards where we take supplies or we stuff it, transmission is affected to various areas when system is centralized. Regular site electrical management or organization is required under direct control of electrical department on project site. A regular site electrical organization is required under direct control of electrical department on project site. Electrical supplies to site for works is really a critical activity, since it cannot be provided in style of permanent works. It cannot be provided in style of, you can say, Regular site electrical organization is required and the direct controls of electrical department. Electrical supplies to site for works is really a critical activity since it cannot be provided in a style of permanent works. Routes of front work cable shall be required to be altering every day. Certain smaller equipment such as concrete mixers, concrete vibrators and lights shall be provided to be operated electrically. Office air conditioners and lights shall be connected to such temporary arrangements. These are all site requirements. We should not forget. It's a very important requirements. And if we say I'm just trying to find a file to show to you because I saved, I think I remember. Radiation basic radiography, safety, scaffolding, scaffolding 2.1, types of hoisting equipment. No, it's not that. I think it's not in this, maybe somewhere else. Detecting radiations, certain items, construction networks, it. No, it's not that. Well, I saved something that I'm not able to find this time. It doesn't matter. Well, we'll see sometime. Radiation chart, quality policy, radiations basics, radiography, safety, fans, scaffolding, what's hoisting. Well, I can't say where is this. Welding, temporary quality, this going to be external utilities, airframe, working at heights, going to be. Let me see if I can do it this way. No, it's not. Let's leave it. I can't. Construction light work safety measures. Camping surface carrier photos. No. Anyway, I'll do this one way. I won't care for this, whatever it is, and it's nonsense. So what I'm saying is really, about this light of stocking. I wanted to show you some page, but I could not trace that. Sorry for that. So I say a regular site electrical organization is required under direct controls of electrical department on project site. Electrical supplies to site for works is really a critical activity. Electrical supplies to site for works is really a critical activity since it cannot be provided in a style of permanent works. Routes of front work cable shall be required to be altering. So I can say electrical supplies to site for works is really a critical activity since it cannot be provided in a style of permanent works. The routes of front work cable shall be required to be altering every day depending on requirements of various locations. Even certain smaller equipment such as concrete mixers, concrete vibrators and lights shall be provided to be operated electrically. Office air conditioners and lights shall be connected to such temporary arrangements. Now, we have certain definitions which sometimes I don't explain, sometimes do, of course. And this is safety. You know what's the meaning of safety? That's safety, health, and environment. Company, you know what is contractor, you know subcontractor, client, personal means, and all that. Training, means of course everyone, management, safety, all these are very common. Employer, contractor, temporary electric is here, means temporary electric is that is, all site temporary power, all site temporary power supply, all site temporary power supply, and distribution systems, electric power tools, equipment and lighting not incorporated into permanent ones. Site temporary power supply and distribution systems, electric power tools, equipment and lighting not incorporated into permanent ones. Now responsibilities in general, that is project manager, leaders, site leaders, this site safety inspectors, site foreman, individual, this all are here, and you can see for a couple of minutes because I'll be back after 10 minutes. We are talking about responsibilities here. Responsibilities, that is, you know, project manager, site manager, safety officer, construction manager. We are all are differently defined. Nothing new in that, and I don't want to waste time. You have might have read by now. I go about what does site manager has to do in this case, that ensure procedures being applied for controls, that is site manager, site leader, that should what it should do, ensures procedure being applied for controls of all temporary electrics through contractor and others. Arrange all required resources to meet site requirements and for maintenance of system of electrical distribution. Health, safety and environment manage. Health, safety and environment manager, Health, safety and environment manager responsible for development of this procedure and monitoring compliance, that is health, safety, HSE, SHE. Construction manager ensure that sufficient resources are provided, that is to implement this procedure, and that procedure is being applied correctly. Electrical instrumentation supervisor assign duties under procedure to persons deemed competent to carry out this procedure. Shall carry out regular audits, monthly minimum or more. You can say monthly minimum, maybe 15 days, shall carry out regular audits of temporary electrics on site to ensure compliance using checklist or whatever attachment is there. Shall evaluate effectiveness and revise procedure when changes are required. Means if there is some requirement of change, you have to revise procedure and provide training and guidance to competent persons assigned for checking and approving temporary electrics. Advise site leader of continual violation. Advise site manager or site leader of continual violations. Competent electricians. What actually electricians are? Main technologists, you can say persons involved in running temporary electrical supply technology practically. Competent electrical person or electricians shall be entrusted with responsibilities. What responsibilities? Maintain a register of all electrical equipment repaired. Tag approved equipment prior to use. Prohibit use of any electrical equipment that does not comply with standards specified in this procedure. Carry out random inspections of existing certified equipment to ensure that integrity of system is being maintained. Means just act random, inspect. Though you can inspect everything, there's no bar, but in random, just for making sure it's running, system is running. Report back to E&I supervisor on certain concerns noted. Then subcontractor. All subcontractors shall be required to comply with this procedure. Very, very simple procedure, nothing very complicated in this procedure. Then instructions. Instructions means guidelines. These given guidelines be followed in checking site temporary electricals, power generators, distribution. Then you can see this is power generations. Generators and welding machines shall be maintained in good condition. Maintenance records be available upon request. Fuel tanks shall be located in bund areas, means embankment areas, rated to 150% of total fuel capacity. Area around generators shall be maintained free of oil and diesel spills. Rotating components shall be guarded. Rotating components like grinder or like something electric saw or whatever else should have guards. Call it shall be guarded. Earth leads. Earth leads to all appliances and equipment shall be provided. Earth leads must. Outlets shall be in good condition with no exposed conductors. Distribution. Distribution boards shall have earth leakage breakers, ELCs. Distribution board shall have earth leakage breakers or residual current devices fitted. Terminal points shall be in an enclosure. Terminal points shall be in an enclosure with feed and outlet cables channeled through enclosure via rubber plastic grommets. Terminal points shall be in an enclosure with feed and outlet cables channeled through enclosure via rubber plastic grommets. Distribution panels be kept locked and keyed, held by authorized personnel only. Cables shall be of size and rating suitable for purpose. Earth leads shall be fitted to all distribution boards and metal support frames. Splicing of cables shall not be allowed. Cables shall be extended or repaired using correct industrial fittings. Domestic standard cables and fittings shall not be allowed on site. All cables shall be to a construction industrial standard and resistant to damage, wear and tear. Particular attention Particular attention shall be given to cable management organization to ensure that cables are routed in a manner that does not create any obstruction or trip hazard. Method of such routing shall be conducted in a manner that does not damage or affect integrity of cable. Main isolation points shall be provided. Main isolation points shall be provided in conspicuous and accessible places. Main isolation points shall be provided in conspicuous and accessible places in workshop, fabrication areas. Machinery shall also have isolation points provided adjacent to equipment. Main isolation points shall be provided in conspicuous and accessible places in workshops, fabrication areas. Machinery shall also have isolation points provided adjacent to equipment. Cable connections shall be done using industrial proof fittings. Distribution panels, boards, circuit breakers, and junction boxes shall be subject to doing scheduled preventive maintenance. Tags certifying good condition, safe for use, shall be attached after such maintenance. Circuits shall be de-energized, supply panels and circuit breakers be locked off and tagged per safe electrical work practices prior to some maintenance would be affected. Again I say, distribution panels, boards, circuit breakers and junction boxes shall be subject to doing scheduled preventive maintenance. Tags certifying to good condition, safe for use, shall be attached after such maintenance. Circuits shall be de-energized, supply panels and circuit breakers be locked off and tagged for safe electrical work practices prior to some maintenance would be affected. Hand tools, electrical hand tools and equipment shall comply with following standards. Shall be compatible with 110 to 40 volts per power supply. Should occasion arise where 240 volts requires to be used, such tools shall be double insulated. Equipment casing shall be intact. With no loose fittings or exposed cables. Plugs fitted shall be of an approved industrial type. Conditions shall be good and tool be subject to preventive maintenance routines. Equipment checklist, electrical tax system. Now temporary electric equipment checklist, what is that? Now we have to write area of that's different. Now what is that? Condition, power generation, let us say what is condition? That is ELCVs, system devices, ELCVs, circuit breaker, electric circuit breaker, RCDs. Housekeeping, then this is power generation, let us say power generation is condition, housekeeping and outlets, and there's safety device, that is, then cables, then what is that? Connections, then we have to say terminations. So these are various points. For example, power generation, cables, earthing, then we have here earthing, then electrical hand tools, fittings. These are few points that we can say that these are better to understand. These are few points. In cables we have connections, important, cable connections, cable terminations, cable condition, cable capacity and ratings, cable routing, cable management. We have to check these and then we can write here like this. Power generation, we have to see condition, we have to see housekeeping, and we have to see outlets, areas this is, and we have to see condition, housekeeping, outlets. This is for power generation. What is condition of power generation? What is housekeeping? How it is What about outlets or power generations? Then we have to go to cables. Cable connections are required, cable terminations are required. What are conditions there for cabling? Capacity and rating of cable, that's more important. Armored cable, or what's capacity it is, what's rating of that, what's route of that, that's organization, how to use it to safely. Then earthing, you can say, earthing, what's distribution boards, connections, earthing, then cabins and offices, and then transformers, generators. In A, when we say A acceptable, or we say UA is not acceptable, this is A accept, not accept, not like that. Then we can see this is like survey. This is, you can say, temporary electric equipment checklist. Now, for example, we come here to earthing. This is here. Now, if we go to somewhere else, it is safety devices. Now, what is safety devices? ELCBs, RCDs, isolation points, and panel lock. These are devices we have to check. Then electrical hand tools, condition of that tool, double insulated sockets and fittings, etc. So let's say A or an AUA available in A, that is acceptable or unacceptable. Then we can say fittings, no exposed cables, wires, condition non-domestic, and then you have to do that practical and equipment detail below has been checked and is certified, and we can write here what are equipments. Then you have to see interference with this equipment shall negate this tag. This is a tag, and alterations required must be notified in advance to undersigned. That's what's important point it in this case of electrical supply. I think it's very small page but very important one. And then we jump onto welding and cutting. Of course, welding and cutting, we go on to this and we see how it works, and possibly if we can see electrical. Now, welding and cutting, this applies to all operations involving use of different types of welding and cutting equipment, accessories and related materials. And in this, what is their purpose, definitions, responsibilities, instructions, so it's very long one, almost simple. So temporary electric supply I can just take off, and we'll go back to now welding. Let us see in addition temporary electric supply welding. Let us see welding. What welding is about. Let us see. Let us see what's welding now. Let us understand what's welding. Welding is a fabrication process. Let us see what it says. That's also important. I'll just take a print out of this to show you. I'm not going to save it because it's just not coming up, I think. It says welding is a fabrication process. Okay, it has come. So I'll put that off first, but that's unnecessary. It keeps loading on this. Let's keep down that one and keep it up here. Let's go through this and see what it says. Okay, it's from Wikipedia. Welding is a fabrication process Welding is a fabrication process. Welding is a fabrication process that joins materials, usually metals of thermoplastics. Metals or thermoplastics, both thermoplastics and metals. Means joins materials, usually metals and thermoplastics, by using high heat to melt parts together and allowing them to cool, causing fusion. It's called fusion. Fusion. Welding is distinct from lower temperature. Welding is distinct from lower temperature metal joining techniques such as brazing and soldering. Welding is distinct from lower temperature metal joining techniques such as brazing and soldering, which do not melt base metal. In brazing and soldering, no melting is done. In addition to melting base metal, a filler material is typically added to join to form a pool of molten material, weld pool, that cools to form a joint that, based on weld configuration, that is butt welding or full penetration or fillet welding, can be stronger than base material, parent metal. Pressure may also be used in conjunction with heat or by itself to produce a weld. Welding also requires a form of shield to protect filler metal. Welding also requires a form of shield to protect filler metals or melted metals from being contaminated or oxidized. I go further. Many different energy sources can be used. For welding, including a gas flame chemical, an electric arc, a laser, an electron beam, friction and ultrasound. These are energy sources. You can just see this energy source, very important one. Now, many different energy sources, we have to repeat, is very important. Many different energy sources can be used, and these are energy sources for welding are gas flame, that is a chemical, that is gas flame, an electric arc, that's electrical, a laser and electron beam. Laser is an electron beam, and friction and ultrasound. While often an industrial process, welding may be performed in many different environments, including an open air welding, underwater welding, and in outer space. Welding is a hazardous undertaking, hazardous, full of danger, unexpected danger. Welding is a hazardous undertaking, and precautions are required to avoid burns, electric shock, vision damage, eyes problem, inhalation, smell, take smoke into your nose, inhalation of poisonous gases and fumes, and of course exposure to intense ultraviolet radiations. Intense ultraviolet radiations. Ultraviolet radiation, exposure to intense ultraviolet radiations. Until end of 19th century, only welding process was forge welding, which blacksmiths had used for millennia to join iron and steel by heating and hammering. Arc welding and oxy-fuel welding were among first processes to develop late in century. Arc welding and oxy-fuel welding were among first processes to develop late in century, and electric resistance welding followed soon after. Electric resistance welding followed soon after. Welding technology advanced quickly during early 20th century as world wars drove demand for reliable and inexpensive joining methods. Welding technology advanced quickly during early 20th century as world wars drove demand for reliable and inexpensive joining methods. Following wars, several modern welding techniques were developed, including manual methods like shielded metal arc welding. Shielded metal arc welding. Now, one of most popular welding methods, as well as semi-automatic and automatic processes such as gas metal arc welding, submerged arc welding, flux core arc welding, and electro slag welding. That is gas metal arc welding, submerged arc welding, flux core arc welding, and electro slag welding. Developments continued with invention of laser beam welding, electron beam welding, magnetic pulse welding, and friction stir welding in later half of century. Today, as science continues to advance, robot welding is commonplace in industrial settings, and researchers continue to develop new welding methods and gain greater understanding of weld quality. What's etymology of this? term weld, this terminology that called weld, is of English origin with roots from Scandinavia. Scandinavia. It's often confused with Old English word weald, meaning a forested area. But this word eventually morphed into modern version, wild. Old English word for welding iron was samod, to bring together, or samod welling, to bring together hot with hot, more relating to red hot, or a swelling rage, samod welling. In contrast to samod faced, to bind together with rope or fasteners. Weld is derived from Middle English term. Weld is derived from Middle English verb well, while plural, present tense welling or welling, meaning to heat to maximum temperature possible, to bring to a boil. Modern world was likely derived from modern world welding was likely derived from past tense participle weld with addition of d for this purpose, being common in Germanic languages of Angles and Saxons. It was first recorded in English in 1590 from version of Christian Bible that was originally translated into English by John Wycliffe in 14th century. Original version from Ishai 2:4 reads, "These shall bete together their swords into shares. They shall beat together their swords into plowshares." While 1590 version was changed to Shalem, well together her swords into well, they shall weld together their swords into plowshares, suggesting this particular use of word likely became popular in English sometimes between these periods. Grecian, Bulgar or Latvian Saudirt, to weld or solder, derived from W or boil. In Swedish, however, the verb was only referred to joining metals and combined with word for iron, jar, as a valla jar, literally to boil iron. Word possibly entered English from Swedish iron trade, or possibly was imported with thousands of Viking settlements that arrived in England before and during Viking Age. As more than half of most common English words in everyday use are Scandinavian in English. Well, leave it now. Now, history of joining metals goes back several millennia. Earliest example of this come from Bronze and Iron Ages in Europe and in Middle East. Ancient Greek historian Herodotus states in histories of 5th century BC that Glaucus of Scios was man which single-handedly invented iron welding. Welding was used in construction of iron pillar of Delhi. Delhi, erected in Delhi, India, about 310 AD and weighing 5.4 metric tons. Iron, we call it iron. Here is iron. Iron pillar of Delhi, India. It is iron pillar. Middle Ages brought advanced in-forge welding, in which blacksmiths pounded heated metal repeatedly until bonding occurred. In 1540, Venocoi Biringuco published De la Technia, which includes descriptions of forging operations. Renaissance craftsmen were skilled in process and industry continued to grow during following centuries. This is all history. I'm just giving you an example. If you can read, you can go to I will like to see now resistance welding. For example, we take resistance welding was also developed during final decades of 19th century. So thermite welding and like that. Acetylene was discovered. For example, acetylene is very important. You can say acetylene was discovered in 1836 by Edmund Davy. But its use was not practical in welding until about 1900, when a suitable torch was developed. At first, oxy-fuel welding was one of more popular welding methods due to its portability and relatively low cost. As 20th century progressed, however, it fell out of favor for industrial applications. It was largely replaced with arc welding as advanced in metal coverings known as flux weld method. Flux covering electrode primarily shields the base material from impurities but also stabilizes arc and can add alloying components to weld metal. World War I caused a major surge in use of welding, with various military powers attempting to determine which of several new welding processes would be best. British primarily used arc welding, even constructing a ship, Fullager with an entirely welded hull. Arc welding was first applied to aircraft during war as well, as some German airplane fuselages were constructed using process. Also noteworthy is first welded road bridge in world, that is in Poland. During 1920, major advances were made in welding technology, including introduction of automatic welding in 1920, in which electrode wire was fed continuously. Shielding gas became a subject, receiving much attention as scientists attempted to protect welds from effects of oxygen and nitrogen in atmosphere. Effects means from effects of oxygen and nitrogen in atmosphere. Porosity and brittleness were primary problems, and solutions that developed included use of hydrogen, argon and helium as welding atmospheres. Shielding gas became a subject, receiving much attention as scientists attempted to protect welds from effects of oxygen and nitrogen in atmosphere. Porosity and brittleness were primary problems, and solutions that developed included use of hydrogen, argon and helium as welding atmospheres. During following decade, further advances allowed for welding of reactive metals like aluminum and magnesium. This in conjunction with developments in automatic welding, alternating current and fluxes fed a major expansion of arc welding during 30s and then during World War. So this is all you can read, means is lot. Just for information, I try to. Now let's go to what is process. That's important. Processing. It's very important part. Now, arc. What is arc actually? Power supplies, and then what is arc? These processes used as welding power supply to create and maintain an electric arc between an electrode and base material to melt metals at welding point. To melt materials at welding point means this is a process that creates an arc, or to maintain an electric arc between an electrode and base materials to melt metals at welding point. They can use either direct current or alternating current and consumable and non-consumable electrodes. Welding region is sometimes protected by some type of inert or semi-inert gas. Welding region is sometimes protected by some type of inert or semi-inert gas known as a shielding gas, and filler material is sometimes used as well. Power supplies. To supply electrical power, necessary for our welding process, a variety of different power supplies can be used. Most common welding power supplies are constant current power supplies and constant voltage power supplies. In arc welding, length of arc is directly related to voltage, and amount of heat input is related to current. Means voltage means length of arc is related to voltage, and amount of heat input is related to current. Constant current power supplies are most often used for manual welding processes such as gas tungsten arc welding and shielded metal arc welding, because they maintain a relatively constant current even as voltage varies. This is important because to manual welding it can be difficult to hold electrode perfectly steady, and as a result arc length and thus voltage tend to fluctuate. Constant voltage power supplies hold voltage constant and vary current, and as a result arc are most often used for automated welding processes such as gas metal arc welding, flux core arc welding, and submerged arc welding. In these processes, arc length is kept constant since fluctuation in distance between wire and base material is quickly rectified by a large change in current. For example, if wire and base material get too close, if wire and base material get too close, current will rapidly increase, which in turn causes heat to increase and tip of wire to melt, returning it to its original separation distance. I repeat this, it's very important. Constant voltage, let us say constant current power supplies are most often used for manual welding processes such as gas tungsten arc welding and shielded metal arc welding because they maintain a relatively constant current, and even as voltage varies, this is important because in manual welding it can be difficult to hold electrode perfectly steady. Because in manual welding it can be difficult to hold electrode perfectly steady. And as a result, arc length and thus voltage tend to fluctuate. Constant voltage power supplies hold voltage constant and vary current. As a result, are most often used for automated welding processes such as gas metal arc welding, flux core arc welding, that is gas metal arc welding, flux core arc welding, and submerged arc welding. In these processes, arc length is kept constant since any fluctuation in distance between wire and base material is quickly rectified by a large change in current. For example, if wire and base material get too close, current shall rapidly increase, which in turn causes heat to increase and tip of wire to melt, returning it to its original separation distance. Type of current used plays an important role in arc welding. Consumable electrode processes such as shielded metal arc welding, consumable electrode processes such as shielded metal arc welding and gas metal arc welding generally use direct current, but electrode can be charged either positively or negatively. In welding, positively charged anode will have greater heat concentration, and as a result, changing polarity of electrode affects weld properties. If electrode is positively charged, base metal will be hotter, increasing weld penetration and welding speed. Alternatively, a negatively charged electrode results in more shallow welds. Non-consumable electrode processes such as gas tungsten arc welding can use either type of direct current as well as alternating current. However, with direct current, because electrode only creates arc and does not provide filler material, a positively charged electrode causes shallow welds, while a negatively charged electrode makes deeper welds. Alternating current rapidly moves between these two, resulting in medium penetration welds. One disadvantage of AC One disadvantage of AC fact that arc must be reignited after every zero crossings has been addressed with invention of special power that produce a square wave pattern instead of normal sine wave, making rapid zero crossings possible and minimizing effects of problem. Let us read this again. Alternatively, a negative charged electrode results negatively charged electrode results in more shallow welds. Non-consumable electrode processes such as gas tungsten arc welding can use either type of direct current as well as alternating current. However, with direct current, because electrode only creates arc and does not provide filler material, a positively charged electrode causes shallow welds, while a negatively charged electrode makes deeper welds. Alternating current rapidly moves. Alternating current rapidly moves between these two, resulting in medium penetration welds. One disadvantage of AC, that's alternating current, fact that arc must be reignited after every zero crossings, has been addressed with invention of special power units that produces a square wave pattern instead of normal sine wave, making rapid zero crossing possible. And minimizing effects of other problems. Now, what is process? One of most common type of arc welding is shielded metal One of most common type of arc welding is shielded metal arc welding. SMAW, shielded metal arc welding, is known as manual metal arc welding. Manual metal arc welding or stick welding. Electric current is used to strike an arc. Electric current is used to strike an arc between base material and consumable electrodes. Says electric current is used to strike an arc between base material and consumable electrode rod, which is made of filler material, typical steel, and is covered with flux that protects weld area from oxidation and contamination by producing carbon dioxide gas during welding process. Electrode core itself acts as filler material, making separate filler unnecessary. Electric current is used to strike an arc between base material and consumable electrode rod. Which is made of filler material, typical steel, and is covered with flux that protects weld area from oxidation and contamination by producing carbon dioxide gas during welding process. Electrode core itself acts as filler material, making a separate filler unnecessary. Process is versatile. Process is versatile and can be performed with relatively inexpensive equipment, making it well suited to shop jobs. This process is versatile and can be performed with relatively inexpensive equipment, making it well suited to shop jobs and field work. An operator can become reasonably proficient with a modest amount of training and can achieve mastery with experience. Weld times are rather slow since consumable electrodes must be frequently replaced and because lag residue from flux must be chipped away after welding. Again, it's important, process is versatile and can be performed with relatively inexpensive equipment, making it well suited to shop jobs and field work. An operator can become reasonably proficient with a modest amount of training and can achieve mastery with experience. Weld times are rather slow since consumable of electrode An operator can become reasonably proficient with a modest amount of training and can achieve mastery with experience. Weld times are rather slow since consumable electrodes must be frequently replaced and slag residue from flux must be chipped away after welding. Furthermore, process is generally limited to welding ferrous materials, though special electrodes have been made possible. Furthermore, process is generally limited to welding ferrous materials, though special electrodes have made possible welding of cast iron, stainless steel, aluminum, and other metals. Gas metal arc welding. Gas metal arc welding, and before that you can see this diagram, which is arc and weld area in shielded metal arc welding. You can see 1, 2, 3, 4, 5, 6, 7 terms. One is coating flow. Coating flow. Two is rod. Two is rod. Then three is shield gas, and four is fusion, and five is base metal, and six is weld metal, and seven is solidified slag. Gas metal arc welding, also known as metal inert gas or MIG welding. It's a semi-automatic or automatic process. Semi-automatic or automatic process that uses a continuous wire. This is semi-automatic or automatic process that uses a continuous wire feed as an electrode and an inert or semi-inert gas mixture to protect weld from contamination. Since electrode is continuous, welding speeds are great for GMLV than for SMLW. This is gas metal arc welding, also known as metal inert gas or MIG welding, a semi-automatic or automatic process that uses continuous wire feed as an electrode and an inert or semi-inert gas mixture to protect weld from contamination. Since electrode is continuous, welding speeds are greater for GMAW than SMAW. Now, a related process, flux core arc welding, FCAW, uses similar equipment but uses wire consisting of steel electrode surrounding a powder fill material. This cord wire is more expensive than standard solid wire and can generate fumes or slag, but it permits even higher welding speed and greater metal penetration. Gas tungsten arc welding or tungsten inert gas. Now we say flux core arc welding uses similar equipment but uses wire consisting of steel electrode surrounding a powder fill material. This core wire is more expensive than standard solid wire and can generate fumes or slag, but permits even higher welding speed and greater metal penetration. Gas tungsten arc welding GTAW or gas tungsten inert gas welding gas tungsten arc welding or tungsten inert gas welding is a manual welding process that uses a gas tungsten arc welding or tungsten inert gas welding is a manual welding process that uses a non-consumable tungsten electrode, an inert or semi-inert gas mixture, and a separate filler material. Especially useful for welding thin materials. This method is characterized by now go to, can we say, this method is characterized by a stable arc and high quality valves, but it requires significant operator skill and can only be accomplished at relatively low speed. GTAW can be used on nearly all weldable metals. GTAW, gas tungsten arc welding, can be used only, not on, can be used on nearly all weldable metals, though it's most often applied to stainless steel. It can be applied to stainless steel and light metals. It is often used when quality welds are extremely important, such as in bicycle, aircraft, and naval applications. A related process, plasma arc welding, also uses a tungsten electrode but uses plasma gas to make arc. Arc is more concentrated than GTAW arc, making transverse control more critical and thus generally resistant technology. A related process, plasma welding, arc welding, also uses a tungsten electrode but uses plasma gas to make arc. Arc is more concentrated than GTW arc, making transverse control more critical and thus generally restricting technique to a mechanized process. Because of its stable current, method can be used on a wider range of material thicknesses than can be GTW. It can be applied to all, because of stable current method can be used on a wider range of material thicknesses than can GTAW process, and it's much faster. It can be applied to all same materials as GTAW except magnesium, and automated welding of stainless steel is one important application of process. It can be applied to all of same materials as GTAW except magnesium, and automated welding of stainless steel is one important application of process. A variation of process is plasma cutting and efficient. Except magnesium and automated welding of stainless steel is one important application of process. A variation of process is plasma cutting and efficient steel cutting process. Submerged arc welding. Submerged arc welding is a high productivity welding method in which arc is stuck beneath a covering layer. Submerged arc welding is a high productivity welding machine method in which arc is struck beneath a covering layer of flux. Arc is struck beneath a covering layer of flux. This increases arc quality since contaminants in atmosphere are blocked. This increases arc quality since contaminants in atmosphere are blocked by flux. Slag that forms on weld generally comes off by itself, and combined with use of a continuous wire feed, weld depositions rate is high. Working conditions are much improved over other arc weldings processes. Since flux hides arc and almost no smoke is produced, process is commonly used in industry, especially for large products and in manufacture of welded pressure vessel. Other arc welding processes include automatic hydrogen welding, electro slag welding, electro gas welding, and stud arc welding. ESW is electro slag welding is a highly productive single pass welding process for thicker materials between 1 inch or 25 mm to 300 mm. Now we can say ESW is highly productive single pass welding process for thicker materials between 1 inch or 25 mm to 300 mm in a vertical or close to vertical position. Gas welding. Gas welding, most common gas welding process is oxy-fuel welding. Oxy-fuel, also known as oxyacetylene welding. It's one of oldest and most versatile welding process. But in recent years it has become less popular in industrial applications, still widely used for welding pipes and tubes as well as repair work. Equipment is relatively inexpensive and simple, generally employing combustion of acetylene in oxygen, combustion of acetylene in oxygen to produce a welding flame. Temperature of about 3100 degrees Celsius. Alright, so we said that equipment is relatively inexpensive and simple, generally employing combustion of acetylene and oxygen to produce a welding flame. Temperature of about 3100 degrees Celsius. Flame, since it's less concentrated than electric arc, causes slower weld cooling, which can lead to greater residual stresses and weld distortion. Though it eases welding of high alloy steel, a similar process is generally called oxy-fuel cutting, is used to cut metals. Resistance. Resistance. Resistance welding involves generation of heat by passing current through resistance caused by contact between two or more metal surfaces. Resistance is generated between two more metal surfaces. Small pools of molten metal are formed at weld area as high current 1000 to 100,000 ampere is passed through metal. In general, resistance welding methods are efficient and cause little pollution, but applications are somewhat limited and equipment cost can be high. I repeat. Resistance welding involves generation of heat between passing current through resistance caused by contact between two or more metal surfaces. Resistance welding involves generation of heat by passing current through resistance caused by contact between two or more metal surfaces. Small pools of molten metal are formed at weld area at high current 1000 to 100,000 ampere is passed through metal. Now resistance, I said, is passed through metal. In general, resistance welding methods are efficient and cause little pollution, but their applications are somewhat limited and equipment cost can be high. Spot welding is a popular resistance welding method used to join overlapping metal sheets. Overlapping metal sheets of up to 3 mm thickness. Two electrodes are simultaneously used to clamp metal sheets together and to pass current through sheet. Advantage of methods include the method includes efficient energy use, limited workpiece deformation, high production rates, easy automation, and no required filler material. Weld strength is significantly lower than with other welding methods, making process suitable for only certain applications. It's used extensively in automotive industry. Ordinary cars can have several thousand spots. It's used extensively. Okay, now spot welding, seam welding relies on two electrodes to apply pressure and current to join metal sheets. Like spot welding, seam welding relies on two electrodes to apply pressure and current to join metal sheets. However, instead of pointed electrodes, wheel shaped electrodes roll along and often feed workpiece, making it possible to make long continuous welds. In past, this process was not used in manufacture of beverage. In past, this process was used in manufacture of beverage cans, but now its use are more limited. Other resistance welding methods include butt welding, flash welding, projection welding, and offset welding. Alright, I think energy beam. Energy beam welding method, namely laser beam welding and electron beam welding, are relatively new processes that have become quite popular in high production applications. Energy beam welding methods, namely laser beam welding and electron beam welding, are relatively new processes that have become quite popular in high production applications. Two processes are quite similar. differing most notably in their source of power. Laser beam welding employs a highly focused laser beam, while electron beam welding is done in a vacuum and uses an electron beam. Both have a high energy density, making deep weld penetration possible and minimizing size of weld area. Both processes are extremely fast and are easily automated, making them highly productive. Primary disadvantages are their very high equipment cost, though these are decreasing now, and a susceptibility to thermal cracking. Developments in this area include laser hybrid welding, which uses principles from both laser beam welding and arc welding for even better weld properties, laser cladding and X-ray welding. Solid state. Like first welding process, forge welding, some modern welding methods do not involve melting of materials being joined. One of most popular ultrasonic welding is used to connect thin sheets of wires made of metal or thermoplastics by vibrating them at high frequency and under high pressure. Equipment and methods involved are similar to those of resistance welding, but instead of electric current, vibration provides energy input. Welding metals, and this process does not involve melting materials. Instead, weld is formed by introducing mechanical vibrations horizontally under pressure. When welding plastics, materials should have similar melting temperatures and vibrations are introduced vertically. Ultrasonic welding is commonly used for making electrical connections out of aluminum or copper, and it's also a very common polymer welding process. Another common process, explosion welding. Explosion welding involves joining of materials by pushing them together under extreme high pressure. Common process. Explosion welding involves joining of materials by pushing them together under extremely high pressure. Energy from impact plasticizes. Materials, forming a weld. Even though only a limited amount of heat is generated, process is commonly used for welding dissimilar materials. Including bonding aluminum to carbon steel in ship builds, aluminum to carbon steel in ship builds, and stainless steel or titanium to carbon steel in petrochemical pressure vessels. Process is commonly used for welding dissimilar materials, including bonding aluminum to carbon steel in ship hulls and stainless steel or titanium to carbon steel in petrochemical pressure vessels. Other solid state welding processes include friction welding, including friction stir welding and friction stir spot welding, magnetic pulse welding, co-extrusion welding, cold welding, diffusion bonding, exothermic welding, high frequency welding, hot pressure welding, induction welding, and roll bonding. This again I name other solid state weldings processes include friction welding. Friction welding including friction stir welding and friction stir spot welding, magnetic pulse welding, co-extrusion welding, cold welding, diffusion bonding, exothermic welding, high frequency welding, hot pressure welding, induction welding, and roll bondings. Now, geometry. One can say, two you can say like that, but overlap, lap. So common welding joint types, one is joint types. Square butt joint, this is two. Sorry, it's not that. Common welding joint type 1, common welded joint types 1, square butt, that is square butt square. Then 2 is butt joint, V butt joint. 3 is lap joint, and 4 is T joint. Solid state welding process is classification. We'll see that one later. It's not clear sketch. Otherwise, let us say what it says. It's not giving a right answer. We'll see it. Welds can be geometrically prepared in many different ways. Welds can be geometrically prepared in many different ways. 5 basic types of weld joints are butt joint, corner butt joint, lap joint, corner joint, edge joint, T joint. A variant of this last is cruciform joint. Other variations exist as well. For example, double V preparations joint are characterized by 2 pieces of material each tapering to a single center point at 1/2 their height. Single U and W preparations joints are also fairly common. Instead of having straight edges like single V and double V preparation joint, they are curved, forming shape of U. Lap joints are also commonly more than 2 pieces thick, depending on process used and thickness of material. Many pieces can be welded together in a lap joint geometry. So it says single U, variation says cruciform joint, now the T joint. Other variations are examples double V. Preparation joints are characterized by 2 pieces of material each tapering to a single center, V joint. 2 pieces of materials each tapering to a single center point at 1/2 their height. Single U and W preparations joints are also fairly common. Instead of having straight edges like single V and double V preparation joints, they are curved, forming shape of U. Lap joints are also commonly more than more than 2 pieces thick, depending on process used and thickness of material. Many pieces can be welded together in a lap joint geometry. Many welding processes require use of particular joint design. For example, resistance spot welding, laser beam welding, and electron beam welding most frequently performed on lap joints. Other welding methods like shielded metal arc welding extremely versatile and can weld virtually whatever type of joint. Some processes can also be used to make multi-pass welds, in which one weld is allowed to cool and then another weld is performed on top of it. This allows for welds of thick sections arranged in a single V preparation joint. There is a cross section of welded butt joint with darkest grey representing weld or fusion zone, medium grey heat affected zone, and lightest grey base material. After welding a number of distinct regions, after welding a number of distinct regions, after welding a number of distinct regions can be identified in weld area. Weld itself is called fusion zone. More specifically, it's where filler material was laid during welding process. Properties of fusion zone depends primarily on filler metal used and its compatibility with base materials. It's surrounded by heat affected zone, area that has microstructure and properties altered by weld. So fusion zone depends primarily on filler metal used and its compatibility with base materials. It's surrounded by heat affected zone, area that has its microstructure and properties altered by weld. These properties depend on base materials behavior when subject to heat. Metal in this area is often weaker than both base materials. Say, area that had its microstructure and properties altered by weld. These properties depend on base materials behavior when subject to heat. Metal in this area is often weaker than both base materials and fusion zone, and is also where residual stresses are found. Quality. Many distinct factors influence the strength of welds. Many distinct factors influence the strength of welds and material around them, including welding method, amount and concentration of energy input, weldability of base material, filler material, and flux material, design of joint, and interactions between all these factors. To test quality of a weld, either destructive or non-destructive testing methods are commonly used to verify that welds are free of defects, have acceptable level of residual stresses and distortion, and have acceptable heat affected zone. Properties. Types of welding defects include cracks, distortion, gas inclusions, porosity we call it, gas inclusion, non-metallic inclusions, lack of fusion, non-metallic inclusions, lack of fusion, incomplete penetration, lame, water, training. So we can say types of weld defects include cracks, distortion, gas inclusions, porosity, non-metallic inclusions, lack of fusion, incomplete penetration, lamellar tearing and undercutting. These are defects. Cracks, distortion, gas inclusion, which is called porosity, non-metallic inclusions, lack of fusion, incomplete penetration, lamellar tearing and undercutting. Metalworking industry has instituted specifications and codes to guide welders. Weld inspectors, engineers, managers, organizers and property owners in proper welding technique. Design of welds, how to judge quality of welding procedure. Specification, how to judge skill of person performing weld and how to ensure quality of a welding job. Methods such as visual inspection, radiography, ultrasonic testing, phased array ultrasonics, dye penetration inspection, magnetic particle inspection or industrial computed tomography can help with detection and analysis of. So what I say, metalworking industry has done this all, and we can say how to judge the skill of a person performing weld and how to ensure quality of a welding job. Methods such as visual inspection, radiography, ultrasonic testing, phased array, ultrasonic dye, ultrasonics, dye penetration inspection, magnetic particle inspections or industrial computed tomography can help with detection and analysis of certain defects. Heat affected zone. Heat affected zone. Heat affected zone is a ring surrounding weld in which temperature of welding process combined with stresses of uneven heating and cooling alters heat treatment properties of alloy. Effects of welding on material surrounding weld can be detrimental depending on materials used and heat input of welding process used. Heat affected zone written as HAZ can be of varying size and strength. Thermal diffusivity of base material plays a large role. If diffusivity is high, material cooling rate is high and HAZ is relatively small. Conversely, a low diffusivity leads to slower cooling and a large HAZ. Amount of heat injected by welding process plays an important role as well, as processes like oxyacetylene welding have an unconcentrated heat input and increases size of HAZ. Processes like laser beam Welding give a highly concentrated, limited amount of heat, resulting in a small HZ. Arc welding falls between these two extremes with individual process. Now, what we say, if let us say some calculations about this, well, I think it's take long time. So what we do, no problem. Let's read this first. If diffusivity rate is high, metal cooling rate is high, and HS is small. Conversely, a low diffusivity leads to slower cooling and large HAZ. Amount of heat injected by welding process plays an important role as well, as processes like oxyacetylene welding have an unconcentrated heat input and increases size of HAZ. Processes like laser beam welding gives a highly concentrated limited amount of heat, resulting in a small HAZ. Arc welding falls between these two extremes, with individual processes varying somewhat in heat input. To calculate heat input for arc welding procedure, following formula can be used. Q is equal to Q is heat input in joule per mm, V is voltage, I is current, and S is welding speed in mm per minute. Here Q is equal to VI into 60. V is voltage, I is current, and into 60 means you are taken in minutes, over S, that is welding speed, mm in minutes, into 1000 into efficiency. So it is, you can say, efficiency is dependent on welding process used, with shielded metal arc welding having a value of 0.75, gas metal arc welding and submerged arc welding 0.9, and gas tungsten arc welding 0.8. Methods of alleviating stresses and brittleness created in HAZ include stress relieving and damping. So we will take remaining part later on. Interesting, I think it was today. We'll take up later on this part. It's an interesting one to note that a good amount of, before going through method statement, we should have good knowledge of welding methods. What do you want to know? Means we should know background of welding. That's very, very important point, important requirement. And that's what we are doing in this case. Now, just a minute, half a minute. Let me show you what actually is and what we have discussed. We have discussed this today. Welding quality input we have done, and welding we are doing. So I think this is our background today we did. Meanwhile, you can say we have to do close down now.